Hello, I'm Rishi Nene with the C2000 System Solutions team. This video will help you get started with TI's C2000 Digital Power Booster Pack and Power Suite, which is a suite of software tools that simplify digital power supply design. The Digital Power Booster Pack is designed to help both analog and digital engineers get familiar with digital control as applied to power supplies. It includes a synchronous buck power stage that is controlled at 200 kHz PWM switching speed by a C2000 microcontroller. The accompanying software project and the supported Power Suite tools allow users to quickly learn the system by starting from a basic open loop excitation to completely closing the loop and tuning it for optimum system performance. To get started with the Booster Pack, you will also need a F28069M LaunchPad with a mini USB cable, a 9V 2A DC bench power supply, and a computer with CCS version 6.1 or newer and the latest version of Control Suite installed on it. Make sure you also have CCS GUI Composer installed. Plug in the LaunchPad to these Booster Pack headers. Make sure that jumpers JP1, JP2, JP4, JP5 and JP7 are populated on the LaunchPad, while jumpers JP3 and JP6 are not. Make sure that all three S1 switches are in on position. Now connect the LaunchPad to the computer. Make sure switch SW1 on the Booster Pack is in its off position. Connect the 9V 2A DC bench supply to the JP1 connector on the Booster Pack with correct polarity. The DC bench supply should be set to output around 9 to 10 volts. Next, open CCS and navigate to View, Resource Explorer. Navigate to Control Suite, English, Power Suite, Development Kits, Digital Power Booster Pack, Example Projects, Out-of-the-Box Demo. Click on Import the example project into CCS. buck_VMC_F28069M project should now appear in the CCS Project Explorer window. Now click the arrow sign to the left of the project name and double-click on main.cfg file. This file displays all the relevant device resources information, power stage parameters, and project options. The main.cfg file also allows you to change different project options, switching frequency, and input and output parameters. You can also invoke the Compensation Designer and the SFRA Power Suite tools from this file. Without changing any of the default parameters, click on Compensation Designer. The Compensation Designer GUI uses the power stage model based on the data entered in the main.cfg file. It allows the design of different compensators to achieve desired closed-loop performance. Now select the first compensator. This is a 2-pole 2-0 compensator which has been provided by TI. Notice that the magnitude and phase plots for the plant, open loop, and the compensator update whenever a new compensator is selected from the list. These plots also update when the selected compensator is changed. The default software supports 2-pole 2-0 compensator. Do not change any of the parameters in the Compensation Designer. These parameters can be changed and experimented with at a later time. Note the bandwidth, gain margin, and phase margin for the default compensator 1. Close the Compensation Designer GUI. We will use the default project options. Save the main.cfg file. We are ready to build and load this project. Click on the Debug button. The default code should compile and load. This process may take a few minutes to complete. Notice the CCS debug icon in the upper right hand corner indicating that we are now in the debug perspective view. The program should be stopped at the start of main. Populate the expressions window entries by clicking on View, Scripting Console, and then opening Add Watch Window vars.js file from the project directory. Enable real-time mode. In the message box, select Yes to enable debug events. We can also open a graph window to look at the output voltage waveform in real time. To do this, navigate to Tools, Graph, and click on Single Time. Change acquisition buffer size and display data size to 400. Select data type as 16-bit unsigned integer. Select a Q value of 12 and a start address for the data buffer dbuff1. Click OK. Click on and enable continuous refresh for the expressions and graph windows. Now run the code by clicking the Run button. Turn on the 9V supply and then turn on switch SW1 on the booster pack. The output voltage should ramp up to 2 volts. To get good frequency response measurements, we need to increase the load. Let's turn on the active load by setting active_LD1_EN to 1 in the expressions window. Also set continuous_on to 1. Now click on main.cfg file and open SFRA. Click on Setup Connection and select the appropriate COM port. Make sure that Boot on Connect is unchecked. Click OK. Click Connect on the SFRA GUI. Once the GUI is connected, click on Start Sweep. SFRA will start injecting different frequencies and collecting the response for frequency analysis. You might also see the effect of this process on the output voltage in the graph window. The high frequency signals riding on the output voltage indicate an active SFRA run. Once the frequency sweep is complete, the response will be displayed on the SFRA GUI. The bandwidth, gain margin, and phase margin should be similar to the values noted on the Compensation Designer GUI. These values may differ to varying degrees based on how closely the model parameters match the actual power stage values. Close the SFRA GUI. Now set continuous_on to 0. Change PID to P2Z_GUI to 0 and set coef_change to 1. This changes the compensator from the compensator designed using the Compensation Designer GUI to a loosely tuned PID-based compensator that has been manually tuned. You can zoom in on the output voltage transients. Note the output voltage spikes whenever the active load is turned on and off. Now change PID to P2Z_GUI to 1 and set coef_change to 1 to go back to the original compensator obtained from the Compensation Designer GUI. Notice how the output voltage spikes have significantly reduced. We have just verified the improved transient performance of the system in time domain. You can now turn off the 9V power supply and optionally close CCS. Once you have evaluated this TI solution, you can use the Solution Adapter tool to adapt the solution to run on your custom digital power supply board that uses the same topology and similar resources. To do this, start with a new CCS workspace. Open Resource Explorer and navigate to Control Suite, English, Power Suite, Solution Adapter. Click on Buck. On the next screen, click on Voltage Mode Control. Specify a destination location for the project and click OK. The main.cfg file should open. Now you can change the resource mapping for different ADC inputs and PWM outputs to match your design. You can also change voltage and current scaling and enter power stage parameters to match your design. This allows quickly adapting the TI software without having to write code. I hope you found this video useful. For more information on the Digital Power Booster Pack, go to the link shown below. Thank you for watching.